Hey everybody, welcome to the Unit 3 or the Chapter 4 review over congruent triangles. In this video I'm going to do pretty much everything on the left side, and everything on the right side will be for you to do. So, that being said, identify each triangle based on sides: equilateral, isosceles, or scalene. Remember, equilateral has all sides the same. Isosceles has two sides that are the same, and scalene has no sides that are the same. So 2, 2, 2 must be equilateral. I'll just put an EQ. And then number 2 goes 3, 5, 7. That's all different, so that must be scalene. So I'll just do SC. Alright. In the diagram, triangle RST is congruent to triangle XYZ. Find X. There it is. That's a joke. So this is where you have to use your congruent parts, corresponding parts of congruent triangles. So if these are congruent, then set this equal to this. And we're also going to find y. It should say find x and y. But so I'll zoom in. There's not much room on this at all, is there? So we're going to say x plus 21 equals 2x minus 14. And then we're also going to do 4y minus 10 equals 3y plus 5. Alright, and so let's get our x's on one side. So let's see here. X is smaller than 2x, so I'll minus it over there to keep my x's positive. And then the y's, 3y is smaller than 4y, so I'll minus it over here to keep my y's positive. And then let's see here. So if I canceled something on the left-hand side on this equation, then I'll also want to cancel something on the right-hand side, moving my constants over. So I'm going to add 14 over right here. And then same idea here. I'm going to add 10 over to cancel one thing on the left side and on the right side. So let's see here. Let's write our final statements. 21 plus 14 is going to be 35, and 2x minus x is x, and then 4y minus 3y is y, and 5 plus 10 is 15. Alright, and then I like to always plug it back in. I like to ask my students, hey, what do the angles measure? So just plug it into one of these statements for x and one of the statements for y. The reason why you only need to plug it into one of them is because you set them equal to each other, so it doesn't matter which one you plug it into, you get the same answer. So I'm going to plug 35 into x plus 21. So 35 plus 21 is going to be 56 degrees. And then I'm going to plug 15 into the 4y minus 10, so 4 times 15 is going to be 60 minus 10, and that'll be 50 degrees. Alright, so we're going to find the value of x. So we have, this is marked as isosceles, this is marked as isosceles. They are not congruent triangles. I mean, you can tell that by appearance, but also the way they're labeled. This is one dash, this is two dashes, so it's like, yeah, you have two isosceles triangles, but they're definitely two different sizes. So this one's actually pretty tricky. It's a good test question. If you have 116 here for your vertex angle, then your base angles will be the same thing. They'll be congruent. And then remember, all three angles add up to 180. So let's see here. What is 180 minus 116? 180 minus 116 is going to be 64. And so these two angles have to add up to 64 degrees. So just cut them in half because they're going to be the same. So 32 and 32. Alright? And then this 72 angles is very important because 32, 72, and this angle right here are all sharing a straight angle line. So they all add up to 180. Alright? So what you're going to do is you're going to go 180 minus 72 and minus 32. and that's going to be 180 minus 104, and so that's going to get you 76 degrees. So that's telling me that this needs to be 76 degrees. And so if this angle is 76 degrees, then this angle is 76 degrees. And so if they're both 76 degrees, oh well, why do I know they're both 76 degrees? Because it's on an isosceles triangle, and these are the base angles, and base angles are congruent. So if these two are 76, they add up to 152. And so I'm going to just do 180 minus 152, and that'll give me 28 degrees. And that is what x is going to equal. So, yeah, that was fun, wasn't it? Next problem, we're going to classify triangle TJD given that T is at -4, -2, J is at 0, 5, and D is at 1, -1. So if we're going to classify it, we're going to classify it as equilateral, scalene, or isosceles. And the only way to classify it when you're given coordinates for your endpoints, or your corners of your triangle, if you want to think of it like that, is by doing the distance formula. So, if you don't remember, this is your distance formula, x2 minus x1 squared plus y2 minus y1 squared, and taking the square root of all that. So what I'm going to do is I'm going to find the distance of TJ, TD, and JD. Okay, finding the distance of TJ, x2 is 0, x1 is -4, so 0 minus -4 squared plus, and then y2 is going to be 5, minus y1 is -2, so minus a -2 squared. I'm just going to go ahead and set these all up. So now I'm going to find the distance of TD. So d x2 is 1 minus -4, and then y2 is going to be -1 minus -2. So there's the setup for TD. Now let's do the setup for JD. So let's see here. J is 0, 5, and D is 1, -1. So x2 minus x1, 1 minus 0, and then -1 minus 5. Okay, so here I have them all set up. You're free to type these into a scientific calculator and get the answer, or you can just kind of simplify what's underneath the radical if you don't want to type that all in, if you're good at mental math. Or you can just type this into a calculator, and then add them together, however you want to approach it. But here's what I'm going to do. I'm going to do it verbally with y'all right now. 0 minus -4, that'd be 0 plus 4 squared. So 4 squared is 16. Oh, I forgot like my parenthesis right there. It's got to be like a double parenthesis. So I have 16 plus, let's see here, 5 minus -2, that's going to be 5 plus 2, that's 7. 7 squared is 49. 16 plus 49 is going to be 65. And I just take the square root of that. This next one, D, this will make 5, right? 1 minus -4. Again, I forgot my double parentheses right there. So 5 squared is 25. And then this one's -1 plus 2, so that's 1. And 1 squared is 1. So this is going to be the square root of 26. And then 1 minus 0 is 1. 1 squared is 1. And -1 minus 5 will become -6. -6 squared is 36. So that'll be the square root of 37. So you could type all these in if you want, but at this point I can tell that these are all 3 different numbers. So this is going to be a scalene triangle. Okay, so this next problem says, determine which postulate or theorem can be used to prove each pair of triangles congruent. If not possible to prove congruent, write not possible. So let's look at our menu of options here. So in this chapter you learned about these 4 congruency postulates or theorems: side, 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 angle, and angle, side, angle. You also learn about some right triangle congruencies, but none of these triangles are given as right triangles. Maybe this one would be, but yeah, we can prove this otherwise though. So yeah, I'm not gonna. All I'm trying to say is I'm not gonna talk about the right triangle congruencies in this example. So looking at this first one here, I'm thinking it is angle side because it's got two angles marked, and then the side that they share is always going to be congruent. So if you look at it, it goes side, angle, and since we don't say SAA, we just say AAS, it's like the same thing. I'm going to conclude that this is congruent by angle, side. This third one, I'm looking at side here because it's got two sides marked and then third side sharing. So if it's sharing a third side, it's congruent. So that means all three sides are congruent. So side. This next one looks like side as well because, or actually, no. This has two dashes, this has two dashes, this has one dash. So that's indicating that these are different measures. So this looks like an isosceles triangle here, and this looks like a different isosceles triangle there. The only thing they have congruent is this shared bottom side. So therefore, I'm going to conclude that this one's actually not possible. So it's trying to trick you into thinking that it is side. And this last one, this side is shared, so that's congruent. So this goes side, angle, side. So yeah, SAS. Okay, so another teacher wrote this review, and they put this Pythagorean Theorem problem on here, and I could have sworn Pythagorean Theorem's covered in another chapter. But most kids are familiar with the Pythagorean Theorem formula, a squared plus b squared equals c squared. So I figure if I miss something, then why not cover it now? So your A and B sides, it doesn't matter which side they are. I usually just say, hey, the shorter side looks like A, the longer side's B. But even if you call this A and this B, then it doesn't matter. As long as you call this side C, because the hypotenuse is always opposite of the right angle. So the right angle always points to the hypotenuse. So all I'm trying to say is you got 9 squared plus 12 squared equals c squared. So that's going to be 81 plus 144 equals c squared. Add those together, you're going to get 225 equals c squared. And so to figure out what c is, that's what c squared is. To figure out what c is, you have to go in and you have to take the square root of both sides to undo the power of 2. And so c is going to equal the square root of 225 is 15. So yeah, even if, like I said, even if we forgot to cover it, I think this is there by mistake. But, you know, even if it is, it couldn't hurt to go over a Pythagorean Theorem problem. Okay, so this last problem says write a two-column proof. Given that PQ bisects angle RPS and angle R is congruent to angle S, prove that triangle RPQ is congruent to triangle SPQ. So what I like to do is I like to draw or label whatever is given on the image. So angle R is congruent to angle S. So I'll put a little curve here. And then PQ bisects RPS. So if you look, RPS is up at the top. So that means if you have an angle bisector, then that creates two separate angles that cuts them in half. So we also know that this is a shared side. And so looking at this, we have angle, side. So if you're given a blank proof like this, work with what's given, label what you can, and then look at, well, how can I prove this to be true? I see that I have two angles marked and a side marked as congruent. So I can use angle, side congruency. So I want my proof to lead into that, okay? So all you have to do is prove that these two angles are congruent and this side is congruent, and then you can prove that the triangles are congruent by angle, side congruency. Okay, so I'm gonna just like kind of loosely draw a two-column proof, but you have your statements on the left and your reasons or your proof on the right. So I'm gonna start with what's given, and that's PQ. You could choose, it doesn't matter which given statement you choose to start with, but I'll start with PQ bisects angle RPS. So how do I know that's true? That's given. Okay, what do I know that leads me, what does that feed into next? Remember I said, okay, if this is an angle bisector, then these two angles must be congruent. So I'll say that angle RPQ is congruent to angle SPQ because of the angle bisector property or definition of an angle bisector. Okay, so now we've proven that these two angles are congruent. So now I just need to move on to, something else, proving that this other angle is congruent or this side's congruent. For me, if I know I'm going to use angle, side, I like my proof to reflect that. It needs to go proving an angle, proving another angle, proving a side. It doesn't the order doesn't necessarily matter, but I just think it's easier to read back to yourself that it goes angle, side, and then you say, hey, this is true because of angle, side. Like if I mix it up and I went angle, side, angle, I can still say it's proven by angle, side because of the way the picture looks, but yeah, when you read it back, it would lead you to believe that it's angle, side, angle. That's my only rationale there. So all I'm trying to say is I'm going to skip over this PQ right now, and I'm going to go to this angle R is congruent to angle S. And then how do I know that's true? Well, that was given to me, at the top, at the very beginning. So now I've proven two angles are congruent. I just need to prove that this side, PQ, is congruent to itself. Because, yeah, that's what it is. It's PQ on both triangles. Our triangle RPQ and triangle SPQ both have side length PQ, or segment PQ, I should say. So you write PQ is congruent to PQ. Anytime something's congruent to itself, that is the reflexive property of equality, which I believe for a triangle is called like the triangle reflexive property of triangle congruency. So just write reflexive property. Okay, so reading it back, now I can tell that it went angle, side. So that's why I like to do it in that order. So the last thing I need to write down is my proof, or the final statement, what you were trying to prove. I was trying to prove that triangle RPQ is congruent to triangle SPQ. And so how do I know that officially? Because of the angle, side property. So there you go. That's going to wrap this proof up, and that's actually going to wrap up the review. So thank you for watching, and good luck on your test, and goodbye.